Welcome to Variations 4, the Lytes and pH unit. We're going to be talking about questions 1 to 3, and that covers ADH, calcitonin, and parathyroid hormone. So if we look at question 1, it's asking us how ADH works. So it tells us to look at map number 1. All the information from these maps is straight from your Lewis textbook. So if we look at the ADH portion of map 1, we start out with a condition. The condition is decreased extracellular fluid. Let's put that in layman's terms for now. We could simply just call that first box decreased blood pressure. Let's just go with that for now. It can also indicate increased solute concentration. Increased solute concentration goes hand in hand with decreased blood pressure, especially if that decreased blood pressure is from dehydration. However, we'll talk more about solutes and we'll talk more about tonicity, and you can come back to this rectangle later on and it'll make more sense. For now, let's just call it a decrease in blood pressure. But know on the side that it could also just be from increased solutes, such as increased sodium level, which again will make perfect sense by the time we finish this unit. So what happens next? ADH is released. Antidiuretic hormone. Now, what does it mean to say that someone is diuresing? It means they are avoiding a lot. So what would you expect an antidiuretic hormone to do? It would inhibit diuresing. It would inhibit voiding. What does that mean? It means the kidneys are holding on to water. They're allowing the body to reabsorb water. They're not excreting water through urine. What effect does this have? The last box tells us that this water will return or stay in the plasma, and so our blood pressure might not fall as dramatically. It may even increase over time as the kidneys continue to hold on to water. Coming back to that solutes portion, if we were able to add water to the blood volume, then our solutes will become more dilute and our osmolality will decrease. If that doesn't make sense to you right now, it certainly will by the time we finish this unit. Question number 2 asks us to talk about the thyroid gland hormone, specifically calcitonin. Again, we're looking at map number 1. So you start with the condition of increased calcium in the blood. What happens next? The thyroid releases calcitonin, a hormone which causes 3 things to happen, all of which will help to increase serum calcium. Will help to decrease serum calcium levels. What are those 3 things? This hormone stimulates the kidneys to excrete calcium. They may help the bone to lose less calcium from its form, thereby keeping it out of the bloodstream and on the bone where it should be. And finally, they oppose the action of the parathyroid hormone. And the result of that will become clearer when we talk about that hormone next. The net result is that your serum calcium decreases, which is what you wanted, and of course the great benefit of having stronger bones. Question number 3 asks us to talk about the parathyroid hormone, PTH. Again, we're looking at map 1. So you start off with a condition of decreased serum calcium. The parathyroid hormone is then released. How does it help calcium levels to rise in the bloodstream? There are 4 ways. Through absorption of the intestines into the bloodstream, resorption from bone, so calcium moves from bone to the bloodstream. What's the problem with this mechanism? The potential problem there is that you lose increased amounts of calcium from bone, and bone becomes weak. You see this all the time with elderly people who don't move around enough and maybe have a deficient diet in calcium as well, both these things. The bones become weak and osteoporosis can set in. The third way comes back to the kidneys. The kidneys can reabsorb calcium into the bloodstream. And finally, hand in hand with that, they excrete less calcium. The net result of all these is increased serum calcium.